All right. Well, welcome everyone. Late Friday here. I just finished up my regular work schedule, and I wanted to jump on a stream real quick here for a pretty short stream today, but still something that I think we can get some benefits from here. If you think the music is too loud here, let me know, and I'm happy to kind of decrease the volume a little bit so you can hear me okay. But yeah, I got some fun weekend commitments this weekend. I got some kitchen design decisions I need to make tomorrow and Sunday, and I got some family members coming by for a visit, which makes it a bit difficult to do the stream this weekend, especially since Nova Code Camp is coming up on tomorrow, Saturday, the 26th, and I'm speaking in the afternoon there about ML.NET. But nevertheless, I don't want to miss an opportunity to continue building on the tool, and I want to make sure that we have time for that and take time for it as well. And I've been doing a little work this week actually on our latest PR here to support Kubernetes deployments, and I've made some really good headway yesterday, and I got something we have to test, but at least I think the big puzzle pieces are there. So today I want to kind of go through that a little bit and see what gaps we have to fill, and if there's something we all can kind of help out with and do. And as always, if you have any questions or thoughts or nudges, let me know. I would be more than happy to do so. But we still have the PR up here. Let me change the music. And there's quite a few files changed here, 26 of them. So I'm not going to walk through all of them. But in general here, we're trying to deploy a container through a registry in Azure or AWS or in Google to a Kubernetes clusters wherever you want to. And that has proven to be kind of an interesting challenge for sure. Definitely a bit more complicated than I thought it would be, but also because I haven't done much Kubernetes before. But now I feel like I know a lot of it. So in general, what we're trying to achieve here for release 1.2 that we're hopefully releasing in not too long, we want to be able to build a container automatically based on the provided schema and the model, push that to a container registry of your choosing, and then eventually push it to Azure or AWS or some other Kubernetes cloud provider. So we have now exposed a method here on the deployment catalog. And remember, the deployment catalog is on the MLOps context. Hey Brett, great to have you on the stream today. Friday evening, Friday afternoon. It's good. I just wanted to start walking through a little bit on where we are with this PR and kind of see how much further we have left, I guess. And hopefully that sounds okay. Let me know if it's too loud, Brett, the music. I'm hoping it's okay. Alright, so we got a couple of to-dos here. And let's see. Where is it? Can you see what this model is? Okay, good. So we have a couple things. Yeah, no worries. So what we've done so far in like 1.2 is that we're trying to do containerized deployments completely. And we've already had support a bit for building a container. And we have that code right here. So build, push an image, async. And as you can see here, what we're doing is we fetch an experiment. We're then downloading the model into this memory stream from whatever model repository we have. And then we're building the image locally. And we're doing that by installing the .NET new templates. We are creating a template project, so that's an ASP.NET Core API. We're copying over the model to the right location within the API. And we're going to fix this just soon, which is going to be what AJ just finished a PR for, which is to generate the model input and output from the kind of typed runtime instances. So this is almost done. We just need a little bit more, and then we can add this. But after that, what we do is we run docker build here to kind of build this image. So it's just a normal docker build command, and I'm not going to go into details exactly on that right now. But once we have that image, we can push that image to our registry. And the registry is whatever a user has supplied. And they can now supply that registry through a builder method, right? So just like we build the MLOps context by selecting the database and the model repo, they can now use a container registry where they will supply the registry name. If it's a public repo, you know, like Docker Hub. If it's a private repo and it needs some kind of authentication, they can then supply the username and password, and we will make sure to log in before we push that to that registry, which is great. So that's like, you know, that's building the image, making sure we have it wrapped up. So we're almost there with that. I'm pretty happy with that so far. The complicated part now is to deploy that image from an Azure or AWS Kubernetes service to, a registry to a Kubernetes service itself. And that's what kind of been working on the last bit here. And that's kind of what we have right here. So deploy container to cluster. And what this does is that it does, let's see, I thought we had, okay, here we go. I thought I wrapped this up correctly, but I think I have a little bit more work to do here. Container sync. I'm just reading through my own code there to make sure I understand what we are doing here. Okay. So this method here is going to be called from here actually, so we can do that real quick here, because they're all kind of granular in case anyone wants to do something by themselves, but I think it makes sense to do them all together here. Okay, so there's to go. It's a bit better. So what it's doing right here now is that we're doing the things we did before, which is building and pushing the image to a private registry. But then we're doing this code right here. We're actually trying to deploy it to a Kubernetes cluster. And what this code is doing here is making sure that the user has supplied anything we need for Kubernetes. And they can do that again through an extension method here called use Kubernetes, and they can supply a path to the kube config. So the kube config, right, is the configuration really to where your cluster is and how it looks like. Get some light here as well. So for example, if you're not too familiar with it, kubectl is the Kubernetes command for doing a lot of these things here. And this is how you interact with your cluster yourself. So if I have a local cluster, which I currently do, I can do kubectl get pods here, and I will get, let's see, kubectl get pods. I can get a list of any pods running. So currently I have one pod running here, which is one or more Docker images within this pod. But if I do want to like reach out to a Kubernetes cluster running in Azure, for example, or in AWS, I can't just do this because kubectl doesn't know where to go. It just knows where to go locally. But I can do kubeconfig like this and pass in a path right here to a config for Azure, and it will then know how to authenticate and do all this kind of fun stuff with Azure. And you can get those kube configs exported from your cloud provider if you need to, and that's kind of what we're hoping users will do, is that they will export the kube configs and provide them to our tools so we can actually communicate with our cluster. So they can specify that here, and what we'll do here is just make sure that we have configured that properly in our context here. Alright, so once they have that, then we can do all the fun stuff here, which is deploying this to Kubernetes. And there's a couple of things to think about here. The first thing is how, like, a cluster, is just a huge, in essence, a cluster is just a grouping of nodes, and each node is a VM of any sort, right? So it has a certain amount of power and performance, and then that's distributed over that, and you can deploy images and pods to those nodes wherever you want to, more or less, and set it up. But a good way to separate certain applications from each other is by using namespaces. And namespaces is something in Kubernetes where you can actually get some kind of separation of concern there. And I can kind of show you a little bit how it looks like here. Let me log into Azure to... Actually, don't need to do that. For example, if you look at a local Kubernetes clusters here, I can get namespaces here. And I'll see here that I have a couple of namespaces already running here. I got the default one, which you get directly when you install a Kubernetes cluster. And I get some Kubernetes specific namespaces right here for internal pods and services. But you can also see I've created a namespace myself here for a review test. And that's kind of what we're going to do as well here, is that we're going to create namespaces with a name of experiment name dash the deployment target name. So for example, if you have a fraud classifier and you call experiment fraud classifier, and we have a test environment, we'll do fraud classifier dash test, and then we have fraud classifier dash prod, and so forth, to find the namespaces and your logical groupings. And the reason why namespaces are so good is because you can apply access policies to namespaces, you can apply resources and resource limits and so forth. So that's a good way for us to organize this, to make sure just some users have access to test and some users have access to prod, so forth. So that's what we're doing right here, is that we are going to create that namespace, and we're going to concatenate the name and the deployment target name here. And then we're going to execute a CLI command here, so kubectl create namespace, and pass in that name, and then specify the kubeconfig path here to make sure we create a namespace in our cluster. So that's the easy part. Then we go into the fun part, which I was doing last night, which I think is working, but I haven't tested, of course, which is deploying a container to a cluster here. Brett or anyone else, do you have any questions so far? I know I'm rushing through this a little bit here, but I'm trying to give an overview of Kubernetes at the same time as providing insight in what's been done so far here. I'll pause for a few minutes here just to have a little drink. Alright, I will continue. If you have questions, let me know. So, what we'll do when we actually apply and send something to Kubernetes, what we actually do is that we use something called the apply command. And what we're going to pass to Kubernetes is a Kubernetes manifest. And the Kubernetes manifest defines things like services and deployments. So for example, we have some examples right here actually, I think. And this is a Jaml file, and it gets pretty complicated real quick here, but in Kubernetes, and let me add a notepad here to explain this. In Kubernetes, the lowest level we can have is a pod. And that's one or more Docker images that we can contain in a pod, right? And you probably heard about pods in general. That's something that's kind of frequently named. But a pod can then be part of a replica set, which then can control, one or more pods. So it's kind of like a load balance of sorts, or like a replica set. So if one of the pods die for any reason, if they have a health check or something, it will spin up a new pod directly for you, which is very useful. But then replica sets themselves can then be part of a deployment, which kind of defines, in this case here, number of replicas and other things here. So it's just like the overall deployment file for a Kubernetes file. And then finally, if you want to expose pods to the world, you can do that with something called a service. And a service is kind of like a load balancer, and it will give you an actual IP address here you can bind the DNS to, so you can expose it to the world. So I know this is kind of rushing through a lot of these concepts in Kubernetes, but I've been reading through a whole book the last few weeks about this to get up to speed on this. But each of these things, you can define them in a Jaml file, which is something like this right here, to understand how things kind of get set up. And this is a deployment Jaml file, and things we define here are, for example, which image we are going to use for our deployments. So which image, when we apply this manifest file to Kubernetes, which image should this pod be based off? And this, of course, is going to be, your registry and then image name, maybe a tag. So this could be your Azure registry. Can't remember exactly how that's, what kind of name that is. And then your image name and stuff. And this is something we're already going to generate by mlops.net, so that's already great. So we can substitute this parameter with whatever image we have decided, right? And other things in here are like number of replicas. So how redundant do we want to make this? I think currently we're going to set it to 1, and then we're probably going to add like configuration parameters for this later. So you can configure this as a user if you want to have, if you have a very high load on your model for any reason, you may want 5 replicas to make sure you get nice load balance solution here. And then also finally here is we can define the resource limits for one of these pods here to make sure it doesn't eat up memory and CPU for any reason. For example, if for any memory leak or whatever. So 1000 M means 1 CPU. And so it's 500 megabytes of 1 CPU. And again, I think we're going to create some basic defaults here, and then in a future ticket we'll make sure we can override these things. So the final thing I want to kind of put your awareness to is this image pool secrets tag here in this deployment manifest. So what we're going to do here is we're going to pull images that we have pushed to a private registry. And we're going to pull them from a private registry that need authentication. So how will the Kubernetes cluster, locally or on the cloud, know what the authentication credential is going to be? Good question, Brett. You have a question about, is it possible to have a memory scale or requirement, or must be defined? I think there's a way to auto-scale as well in Kubernetes. I mean, there's definitely a way to do that. So we could probably look into that actually. That's a really good idea. Great idea. I think we'll have future tickets looking into those kind of requirements and those kind of configuration parameters, but I really like that idea. Auto-scaling is probably the best way to go here. So back to the pool secret. We have to create a pool secret and we have to give it a name. And that's something we have to do as well in mlops.net, which will more or less provide the Docker credentials to log into our registry, and then give it a name and we'll match it here. And the other thing we want to do, once we have defined our deployment manifest, we need to define our service manifest. And the service manifest is going to make sure that this is actually accessible from outside the cluster. If you don't define this, the only way to access this is from within the cluster itself, like from an internal cluster IP address. But defining a service here is going to define it's going to make this available, in this case on port 30,001 here for the outside world. And the most basic thing to do is a node port, but you can also use a load balancer or any open source solutions such as NGX, I think, as well, to do this. But we'll keep it as simple as possible right now, and then once we ramp up on this and actually make it work, we're going to change this, make it more configurable. So these are kind of the things we need to apply here. We need to apply the deploy YAML and the service YAML here somewhere in our code. So I show you all that because I want to give you a background on what we're trying to do here. So when we see this right here, create image pool secret, what we're doing here is we're sending in our settings from Docker and Kubernetes, which contains, in this case, the username and password here, and some other stuff. We're then passing that to the kubectl command here to create a secret in the Docker registry that is called, in this case, mlops.net. That's the default secret name. And we're providing, the Docker server here, which is either in Azure locally or somewhere else, the username and password, and the kubeconfig. So that's like a way just to create this secret. I'm glad, Brett. I'm walking it through myself as well, just to make sure I remember correctly, because this is really complicated and there's a lot of steps here. And for someone, especially like me, that's very new to Kubernetes, this has been a great way to learn Kubernetes. So hopefully I can share some of the thing I've been picking up here. So image pool secrets. Once we've created that, we have created a secret in the Kubernetes cluster for our image repository that we have to have authentication for. So that is great. The next steps here is that we see in those two manifests, and what we'll do here eventually is we're going to execute this apply command here with the manifest, right, to apply them to our cluster. So we'll do the kubectl command, we'll call apply, and we'll use the file itself here and the Azure or AWS configuration to our cluster. And that will, tell Kubernetes to, hey, pull this image, spin up these pods in this configuration, expose this service to the world. And that is great. And we will do that for both the deploy and the service manifest. But before we do that, these needs to be highly configurable, because again, they need to be based on what the client or the user of this tool is going to do. So we have these, I have created a manifest parameterizer, I guess, to pass in parameters like experiment name and image name and replace these values in this manifest. And the way I've gone about this, and there's probably a better way of doing it, but the way I've gone about this is I created two embedded resources here for these manifests. So I created a deploy manifest here, very similar to what you saw before, but they have placeholders like this, experiment name and image name here. And when we go ahead and try to parameterize this, what we'll do here is we pass in the experiment name and image name, and we're just going to read this resource. So pretty standard stuff here. We're just getting our embedded resources, right? Reading that to stream and passing back that string of this file here. So we're passing back that stream here. So this is a string. And then we're replacing everywhere where we have experiment name with the actual experiment name. So whatever the user supplied. And we're replacing the image name here with the image name the user supplied as well. And the same thing here with the deploy or the service YAML here. We have the same kind of placeholders here for experiment name and namespace name. So which namespace we want this service to live in. And we can then do the same thing with the service manifest here and replace those things. So in theory, this should work. Because this is like, building the image and doing all this kind of stuff here to make this work. So I really hope it does, because I haven't tested it yet. So there's a couple of improvement stuff here that we can do. I've created a couple of unit tests here for this. But what I want to try to do here is see if we can go all the way through here. to make sure that we've actually got a solution that works. And then from there, you know, we can start building out the configuration stuff and all the nice bells and whistles. But without actually getting something to a cluster and serving it, it's kind of pointless. So an issue I have is that I do not haven't found the container that can run Kubernetes in. So we can either not have integration tests for this, which is not great, or we can have tests that hit a container registry in Azure and a Kubernetes cluster in Azure on my account that can be used to run our CLI tools with. That's definitely a possibility, but I'm not sure. I'm getting some dropped frames here, I'm not sure why. Hope my connection is not too bad. Okay, it's back to green, good. So we have, I guess, I have two solutions here. One way is that we build this package locally and then use a local command solution to try to just kind of do this ourselves. And I think that's what I want to do, because I don't know if we're really ready for integration tests yet, given that we're still experimenting with this solution here. Let me know if that makes sense. So what I'm going to try to do here is I'm going to package this up locally and see if I can create a local solution to see if we can get this to function as expected. So what I'll do here is pull up a command prompt here. Just try to make sure that things are working as expected here. So we can go and look at this. Okay, ml.net. So if we go into our library right here, right? Let me zoom in a bit here so you can see better. We should be able to do the .NET pack here, I think. Two packages up. Okay, perfect. So now we have a package here. So what we can do is open up a new studio. And let's see if we can, I think we have a solution already actually. Let's do this. Let's use the ml.net new templates here that we, actually no, I don't think that's a good idea. Good question, Brad. So it's a security risk could have replaced experiment name. Should pass in this name and replace some with name. I don't think so, given that it's their cluster. We're not necessarily, they have to authenticate against their own cluster, so without that they can't do anything. They are the only thing I think could be an issue is the namespace, but we're only allowing them to create a namespace, not deleting a namespace. Definitely something to think about if there are any risks with it. We're currently not necessarily deleting anything. If they change the deployment here, yeah, I think we should be okay. Something to think about for sure, but I don't really have a good answer to you right now on that. I don't see any issues directly at least, but I also have very limited Kubernetes knowledge. So we may have to loop in some experts here. Yeah, absolutely. Security questions are a good thought though. Alright, so let's see. What we're gonna do here is see if we can spin up a trainer here real quick to deploy it. And I wonder if maybe it's easier to just use the example solution we have actually. Let's not use this one. We already have an example solution. We can just use that instead. And that should be a good one. Okay, this is source repos. We don't want to do that, so ml.ops.net, perfect. So we have the samples here, right? So we can go into samples, open this up. Alright, so let's go ahead and modify this one right here. And the first thing we're going to do is make sure we have a local NuGet feed here as well, so we can get our own package here. So let's see, package sources, right? And we can update this one to be the location where we built this package. It's going to be under C, under Git, it's going to be under MLOps.net somewhere. Sources, MLOps.net, bin. I think it's here. Let's see. So we should be able to right click here, manage NuGet packages. And let's see. If you're lucky now, we should have a local one show up here. And it doesn't seem to, so let's make sure it actually is there as well. Bin, debug. Oh, okay. It's up one level up, that's why. And that's all good. Tools, options. So it's not all the way down here, it's right here. Let's refresh that. Okay. Updates. Let's see. Why don't we have what I need here? Oh, it's because I go to NuGet.org, sorry. Let's go to, I guess, download. Okay, here we go. So here's the package we need. Let's go ahead and install that. Do we need, probably also need SQLite, honestly. Okay. Let me do that real quick here. And I'm not sure if this is a good idea to do it like this, but right now I'm a bit lazy. Okay. Let's refresh this. Okay, perfect. Okay, so we need to update MLNet here, that's all. And then we should be good. So the issue right now is that we have using ML.NET 1.52 here, which is older. Update this one. Okay, great. Yes, think updated. Let's go ahead and switch this over again. MLOps.net. Let's see if this works better this time. Okay. That seems to be work better, at least that's good. Okay, so let's go in here. Have we any build errors? I don't think so. Alright, so now we need to do other things here, like container registry, right? So we need to figure out what these things are. Because the things we need to do here is we need to define both Kubernetes and container registry here. So kubeconfig path is a simple one. Let me open up a new one here and figure out what that is. I've already pulled the one from Azure earlier, so I think that shouldn't be too much of an issue. Let's see, did I put it there? Maybe I put it under C actually. Yep, okay. So that's an easy one. So I'll just do this kubeconfig. Escape those. So that's going to be my Kubernetes file here. And then what we need to do here is figure out the registry name, username, and password for Azure. So let's open up Azure and just show you at least, and then I will show you where to get that in a bit. But first, let me log in here on the separate screen. Okay. Registry, where are you? So here's my Azure, and we have mnet container, and I think there's a command here to view this. Let me see, I thought I wrote it up on the, maybe in a comment here actually, on how to get these credentials, because they're always like, I always forget how to get these credentials. Let's see here. So this is how you get a kubeconfig, by the way, if you want to do that through Azure. But we've already done that, so that's not needed. But we do need to get the login credentials for our image. Okay, let me search for it real quick. Get show credentials. Get credentials. Azure. Okay, so I think we want to do this one right here, and that's going to give me everything I need, but I'm going to obviously put that over here, so it's a little secret, and I need to figure out how to do that on a screen here. So I'm going to do it like this right now so I can show it later, but let me initialize this this bash script here to get these, so I can do that, and then from there we will make sure we get the right credentials here at least. 1 second here. Azure Container Registry. So something I can show you already, which doesn't really matter too much, is the login server. So that's like how you would do it for a login server. And for the credentials here, paste. It's not the correct syntax. Okay. Let me run that command on the side here. Okay. So one thing that's pretty obvious that I'm just going to show you, it's fine, it doesn't matter, is the username. So the username is ml.net because we have the same one here. The password now, though, on the other hand, is something that I'm going to pull over here to apply real quick. And that's something I can always regenerate, so it's not the whole world, I guess, but I'd rather keep it away from recordings. Okay. Alright, so let's pull this over again. Have some fun here. Okay, so now I've added that. Perfect. Sorry about that, guys. So the config file, great question. So the kube config file, if that's what you're thinking about, Brett, the kube config file is something that comes from Azure. So let me clear this right now here. So let me show you here. So you see here I have my registry right here. This is my container registry. I have my container registry, and this is where we're pushing our images for Docker to. And then I have my Kubernetes service right here. This is where I'm going to deploy my images to. And in mlops.net here I have my namespaces, and I have those kind of fun stuff here. And we want to create a new namespace here, of course, and then deploy our pods to it. That's gonna be the end goal here. But if you want to get like credentials and stuff like that, what you want to do always here is open up a new prompt here, like a Cloud Shell, and then you can do things like, for example, let's see, you for example can do this to do an AZ Azure Container Registry credential show, and then the name of the container registry, and that will give you and show you your username and password for that one, so you can paste that in. And if you want to do the same thing for like your kube config, for example, let's say you want your kube config file here, what we'll do here is we'll do this command instead here, and I won't run it, but I'll at least show you how it would look like. It would be paste. So we would this like that, right? So in our case here, if we would run this, actually I can run it because it's going to merge, I think, into a file. In our case here, the resource group here is ml.net container, and you see it up here on the breadcrumb here. And the name here is my Azure Kubernetes service name, and that is the service name we're looking at right now, so that's mlops.net here. And then what we're saying is, okay, what's the name of the file I want this to be exported to? So I call it kubeconfig here. So if I run this, what happens is that I will actually have a new kubeconfig file created here. If I run dir here, I will see I have a kubeconfig here on my cloud drive here, in my Cloud Shell. So if I want to get this one, you can actually go ahead, I think, and download files, I think it's called. So you can actually download this file here, and I can select the file, and you can download to the disk. So that's the way you will get your configuration settings for your Kubernetes clusters in the cloud. Call the config rather than the user defining a file path. Could you elaborate a bit more on that? Exactly. Are you thinking that mlops.net would be executing these commands to get this kubeconfig, or what are you envisioning, Brett? Because I'm definitely curious about anything that could simplify this process a bit. I know there's a delay in the stream, so that's why I'm waiting for you to answer if you want to. No rush. Let's see. While you type, I'm going to continue with this. So we see we have all these things here, and we have done a deployment here. But I can skip this at least. So let's see. Okay, so you're asking if there's a separate step, one can get call a method that gets that rather than download point. Yeah, I wish there were, but in that case we have to authenticate against Azure specifically, and then we have to provide other credentials and a service principal, and that gets complicated. And then it's going, the issue as well with that, I've been thinking about the same thoughts, Brett, for sure. I think it's a great idea because it would be nice to simplify this. But then we have to also think of like how do we do it in AWS, and how do we do it in Google Cloud, or how do we do it locally? And all these are going to have a different CLI flavor. So like Azure uses the AZ and AWS uses something else, and it becomes very like specific for them. So I'm trying to keep this like very Kubernetes native. So anyone who kind of more familiar with Kubernetes can just understand what we're asking for, and how they get that is kind of up to them, really. Yeah, exactly. But it definitely come with suggestions though, because I want to make sure this is as simple as it can get. And with my current knowledge, which is limited, but with my current knowledge, this is as simple as it gets. Alright. So now we want to do this deployment, right? But we don't want to do a URI, we want to do it through container. So we should have this deploy container to cluster, deploy model to container sync here. And we can pass in the deployment targets and the registered model and this. And if we're lucky here, they should do a lot of stuff, and they should hopefully at least create a namespace or something. So make sure we have a good name for it right now. Okay, perfect. So let's go ahead and run this and see how much breaks, because it's possible that this is not going to work at all. I have no idea, but I'm really excited to try. So go ahead and kick this off. And see what happens. Fingers crossed. If this even remotely works, I'm having a lot of celebratory drinks tonight. Okay, training the model, that's all good. Okay, perfect. Logging some metrics, saving the model, uploading it to your artifact, registering model, deployment target is good. Okay, so here we go. How much will it break here? I don't have any logging unfortunately, so I don't know how much it's going to really break, so hopefully it's going to be a good exception if it doesn't break. But while this is running, we can look at the background here and see what's happening. So we know where it's doing stuff at least, right? Okay. We got a good exception at least. Alright, so it didn't really work. The issue we ended up with was the docker build command here for this. And you can see why actually, and this is a great new let's see here. This is a great learning experience here. So I don't think we have space in the Docker name here. And currently what we're doing is we're trying to use experiment name as the image name, as you can see here. And then the registered models version is the actual version. So we definitely need to have a ticket here to remove any spaces. So we need a new ticket for that. But let's see if we go ahead and remove those ourselves, if we can get this to work. So you see here, this is the name here. Let's call it Titanic Predictor instead. And let's see if this works better now. It's possible. But that should be a new GitHub issue for sure, to make sure we can do it in this PR. That we don't allow spaces in names here. Okay, let's see if this works better. It's doing something, and we can look again what it's doing, because it's going to be under samples, and we can see under the bin folder, I think, that we have an image folder hopefully. Okay, so image here. So this is the folders created for us to generate the image. So this is the model, it's just copied over. This is the Docker file it's currently running. So hopefully it's doing something here. So this is like installing the MLNet templates worked, creating the template worked, copying over the model worked, which is great. And now it's running some kind of Docker build command, hopefully, or it's running the Kubernetes commands here, and I have no idea which one. And we probably should see if we can do a console write line here to at least give that information out. I'm not sure if it's going to give us all the way to this host here, but we can try at least. Almost. Alright, so we managed to build the Docker image. That's at least good here, but let me at least what we are doing. But we couldn't apply the service manifest here. So we probably at least managed to create a namespace here. Let's see that. So if we're lucky here, let's see, we should have, look at that. So we are at least able to communicate with this cluster because we're able to create a namespace here, which is the name of the experiment and dash the deployment targets. That's good. But we failed on something here, and we failed on the service application here. So we probably applied the deployment here at least. Okay, so we can't use the port here, 3008. Thanks, Brett. I appreciate the subscription. Such a loyal, loyal follower. Really appreciate that. So, well, welcome back. Not sure if you follow them. So, okay, cool. What happened, Brett, is that we actually pretty close here. So we managed to figure out why it was not building. So it failed on Docker build first, and that was because we have spaces in our experiment name. But we fixed that, so that's all good. We have to add a ticket to remove those spaces. But now we passed that. It creates a namespace in Azure for this, so that's good. And now it's failing on the apply here. And yeah, exactly. So we seem to have the port already allocated here. So we need to figure out a better port number here. And I'm not sure exactly what to do there, but what we can at least do is we can check that, change that real quick, build a new one here, and try again. So we're currently exposing this port on 3001 here. So let's put this on 3099 instead for some reason. I'm not sure that's gonna work, but you know, why not? I think there's a certain port range we can use. I'm just not sure which one here. And other things I want to try here is I want to see if we can add console write lines here to at least spell out what we're doing here. I'm not sure if you're going to see that, but I want to see if we do. So for example, retrieving experiment. Because this is such a long-running process, I feel like we need some kind of logging here, if possible, to see what's happening here. And here, for example, creating namespace. And then we're going to go ahead and add this here. Deploy container, right? Creating image pool secret. Parameterizing manifests. Applying deploy.jaml. And I don't really like this kind of logging, but this is a long-running process, so I do want us to know what's going on here. Service, and then in the build and push image here, delete image. Actually, we can do that in here instead. No need to do that here. Installing new templates. Creating template project, right? And then running build. Actually, I wonder if it's easier if we just go ahead and, I know you'll hate me for this because I'm removing stuff here, but we do have our CLI executor here, so it's almost more fun to do that here, because this is kind of where everything is happening in a way. This is where we execute these commands here. I think it makes more sense to do logging here instead. Running. At least we keep this in one place. Okay, and then let's see. Installing .NET new templates. Creating template project, running Docker build, runner Docker logging. That's fine. Don't need to say that. Docker push. Namespace. Okay. Okay. Almost done with the potential comments here, so we can at least understand. Okay, perfect. So let me remove some of the comments I did here, and then let's go ahead and package it up and see if this will be useful for us or not. Okay. Alright, so let's go ahead and build this. So Windows Terminal, where did you go? There you go. Pack this up. So what we did here is that we changed the port number, and we also added some more logging. So hopefully we'll get some more output what's going on here in the future, which is useful. Okay, that's done. And now hopefully what we can do is go into samples here and change this. Do we have any more releases here or not? Let's see. I'm going to move this over, I think. Okay, SQLite. Let's see, I knew I had the file is not here, it's going to be under mlops.net source SQLite. Let me go ahead and change the local feed here to this one directly, because this is where it's going to be. And it's going to be easier for me to do that. Okay, so tools. I feel like we're so close to getting this to work. This will be exciting. Right. Uninstall this one. And then let's go ahead and install it. I think this was the new version. Let me double check. Node 084. That's currently built. Yep. Okay. I think that's fine. Exactly, yeah, because the mlops.net should be already containing SQLite here. So it should already have pulled in all the dependencies it needs, hopefully. And I don't think I actually need to build mlops.net here. That's why I skipped it. We'll see if I'm right, but I'm pretty sure it's going to work. Because generally when you use the SQLite package, it's going to bring in the mlops.net package as well. Let's see. Okay. Alright, let's see if I continue here. Do we get any console write lines? Okay, so I'm not getting console write lines, and that, you know, can be good or bad. Maybe this doesn't give me console write lines. But at least what I should get here eventually is either a pass or a fail for the kube apply, because it changed port number. So if this is the latest model, then at least a worst case scenario is going to complain about the port number also be taken, but it should be a new port number and not the old port number. And that's always helpful, at least to know. So let's see here. Okay, it failed, and is it the same port number or a new one? Okay. Yeah, I know. Okay. I thought I already captured that exception. So apparently if namespace already exists, then it's going to throw an exception. And I feel like I already fixed that. Because I thought I had like a... Okay, well apparently I throw a new exception here. Okay. I'm not really sure to check if a namespace exists or not. So what I'm going to do here is just be very bad by just capturing it and not doing anything with it. And I'm going to say intentionally left empty. Okay, let's try this again. And I know it's a little bit bad, but that's going to be what we do with it here. Okay, the same one. So if you run this again now, I just don't really care about if the namespace is fails. It's not the whole world. It is what it is, kind of. So I'm gonna just avoid that and see what happens. So now we are running this again. Hopefully it pulled the latest here. I'm a little bit sad that we don't get any output here though. I was hoping that we can get some output for console write lines. I guess what we can pass in is a method here for logger. So we can probably add as an overload where they pass in a method that takes a string to log, and the user can decide themselves how they want to log that. Huh, okay. I think we're not getting the latest actually, because this should have worked. This should have worked. Maybe you're right, Brett, because it's not necessarily... It's not building the latest here. And I wonder if because my version's off. Let me see, let me do this. Let me change the version here. And make sure we trigger a new one at least if possible here. So let's pull this up to 1 here, just to force a new version here. Let's do that pack here. And if nothing else, we should get that 0 to be 1. And that should hopefully at least trigger it to pull down new sources here. Yep, see, okay, so that's a 1 now. So if we now go and do this, hopefully it should pull the latest, because I think it's cached whatever we had before, which is not very helpful. Okay, refresh this. Okay, so So we have an update here. Okay, perfect. I think my wife wants pizza soon, so we'll see how long I can stay on this stream. It's Pizza Friday. But this is exciting, so... okay. Why is it failing? Why is it failing? Package source. So we couldn't pull that, and we all want pizza. I think you may be right, Brett. I think we may have to build mlops.net here. Let me pack it up as well and see if that helps. Okay. Git source. Let me move those things over. I'm not sure that's going to help, but you know what? Why not? So here's this one. This is the tricky part of doing it locally. That's why I always like having these things automated on our build server. Okay. And. Okay. Let's install that one. Let's see if you can get this one too then maybe. Okay. At least no errors now. Yes, okay, that's much better. I think you're right, Brett. We need to do both actually, at local at least. Interesting. Okay, let's see. Maybe we're lucky now with the console write lines too. Maybe that actually works now. Hopefully. Okay, let's see. Keep going here. Yay, look at that. We're having logging now as well. So those console write lines are actually useful. You see how we're installing new templates, creating template projects. So that's actually pretty useful. I think we'll keep them. It's a simple way of notifying the user what we're doing and ourselves as well right now. Okay, so it failed again on the last step here. Or actually, no, it doesn't fail on the last step here. Okay, so secret already exists. I know that. And why are you doing... Okay, that's fine. So we have a couple of commands here apparently that will fail, and that's okay. Alright, we're really close now. This should be secret here, so we don't really care about this. I'm a little bit surprised. We have to check up at some point here if there's a better way of doing this. So for example, if there's a way that we can more easily check if the secret already exists here, because I don't like forcing errors like this and ignoring them. Okay, but let's go ahead and build this up again, the pack. I think we are very close now. Let's go ahead and do this SQLite one. And then let's copy things over. Okay. And copy this one over to SQLite one. That's where we have our local NuGet repo right now. And go ahead and update this in samples repo, run this again, and this time it should hopefully work. And if it doesn't, we have at least got a lot closer here to the final solution. Okay, both of them on 2, perfect. Let's go ahead and run this. I'm just going to take this away because I know it's going to run now, and we'll see the whole flow here from start to finish. Okay. Installing templates. It's a quick one. Well, kind of apparently. Creating projects. So that's removing the old one and a new one. Wow! Look at that. I think we actually passed the whole thing here. Let's see, what do we have in Azure? So hopefully we should still have this namespace. We do. And I don't know if I can see much more here, but we can see that we have... Okay, we have the Jaml files here, and that's good. And yeah, I know, pizza time. Let me check if we can actually communicate with these. I don't think that they actually work, because we still have the issue with the model input output not being copied over. So it's not fully functioning images, but I want to see if we actually have them up and running here. I do think that that's the case, and I want to prove that to you by checking that. So what we can do here is we can use the command line again, called get pods here, or actually get service, I think. Okay, this is locally, so this is the local one, so we skip that. But if we do that and do kube config here and do location of the kube config, we'll see here that we have one in Azure too. And you can see that we have the review predictor here. Interesting enough, running on 3001 here. And that's a node port. And let's see here. Can we get pods here? Okay, it's running. Yes, this is definitely ours, because you can see here that this is 99 seconds ago. And okay, the review predictor here is not what we want though, so we definitely have something maybe not working yet. But we have the pod running, and it's definitely up in the cluster, so it's pulled the image properly, which is great. But I need to see if we can find the servers in the deployment here. So we see here we have Titanic predictor here, and it's been deployed. That's the general one here. Services. Okay, and I think, can we do namespace here? Titanic predictor test. Okay, here we go. So we have to specify a namespace to get the actual service here. But you see here that we have one up and running. We have a cluster IP here. We have no external IP yet, and I think we have to figure out how to do that. But yeah, I mean, the pipeline works, which is amazing. We can pull the image, we can build the image, we can push it to Kubernetes and pull it from the container registry. And we actually have it up and running as some sort in the cloud right now, which is actually a lot more than I thought we would achieve today. So we have a lot of more details to cover here to make sure we have a functioning one. And I'm going to keep that for other streams and keep that for side work on the side here. But this is super motivating. We are pushing forward on this tool. We are building something that is super useful, and I'm really excited to see the pieces come together. And I'm excited to also learn new things about Kubernetes myself. So hopefully you all have learned something today. And Brett, thank you for chiming in. And I will get some pizza now and enjoy my Friday and enjoy my weekend. And I hope you do the same. So thank you all. Bye guys.